You know the feeling, right? One day, your door just glides shut, smooth as anything. The next day, you're practically hip-checking it to get it closed. Well, the answer isn't magic. It's science, and it's hidden deep inside the wood itself.
So let's dive in. We're going to take a closer look at this material that we see literally every single day, but maybe don't really understand. We're going to break down the key physical properties of wood that explain, well, everything, from why it warps to why it feels warm when you touch it.
And first up is probably the single most important factor that dictates how wood behaves. It's, let's call it a complicated relationship with water. Yep, this is the absolute heart of the mystery behind that sticking door. Okay, there's a key term here. It's called hygroscopicity. I know, it sounds super complicated, but all it really means is that wood acts like a sponge. It's constantly trying to match its own moisture level with the humidity in the air. So on a humid day, it literally breathes in moisture, and when the air is dry, it breathes it all back out. So to really get where all that moisture goes, I want you to picture this. Imagine wood's structure isn't solid, but it's actually a massive, tightly packed bundle of microscopic, hollow straws. This amazing structure is exactly what makes wood's relationship with water so dynamic. Now, inside these straws, water actually lives in two different ways. First, you've got free water. That's the easy one. It's just liquid filling up the hollow parts of the straws, kind of like water sitting in a glass. It comes and goes pretty easily. But then there's impregnation water. This is the water that's actually been absorbed into the walls of the straws themselves, like how a paper towel soaks up a spill. And this water, it's much, much harder to get rid of, and it's the real key to understanding why wood changes shape. Okay, this brings us to a really crucial number, about 30%. This is what's known as the fiber saturation point. It's that magic moment when the cell walls, our straws, are completely full, totally saturated with that impregnation water. Any extra water after this point is just free water sloshing around inside. So why does this matter so much? Because wood only starts to shrink when its moisture content drops below that 30% mark. And here's where it gets really, really interesting. As the wood dries out and starts to lose that water from its cell walls, it shrinks. But, and this is the absolute kicker, it doesn't shrink evenly. Not at all. So get this. Wood shrinks a ton along its growth rings, tangentially, but only about half as much going from the center of the tree out to the bark. And along its length, it barely shrinks at all. It's almost nothing. This totally uneven movement is what causes wood to do all those weird things: warp, cup, twist. And that right there is exactly why your door swells across its width in the humid summer and gets stuck at its frame. Mystery solved. Okay, so we've cracked the case of the sticky door, but wood's whole deal with water is really just one piece of the puzzle. Let's move on to our next big property, density. This is basically how heavy the wood is, and trust me, it tells you a ton about its character. So what's the difference between light and heavy woods in the real world? Well, think of it like this. Lighter woods are usually softer and way easier to work with. But on the flip side, heavy woods are super strong and durable, but they can be a real pain to cut and shape. It's why you'd build a delicate model airplane out of something like balsa wood, but you'd want your dining table made from a dense, sturdy oak that can take a beating. And here you can actually see the numbers behind it all. This table breaks down different wood types by their density. You can see pretty clearly that hardwoods, the ones from leafy trees, tend to have a much wider and higher range of densities. Softwoods, which come from pine trees and other conifers, are generally on the lighter side. It really gives you a feel for how big that difference can be. All right, and tied very closely to density is our next property, hardness. This is simply the wood's ability to resist getting dented, scratched, or just worn down. And why does this matter? Well, it's the whole reason your hardwood floors can handle kids, pets, and dropped furniture, while a softer pine floor might get a dent if you just look at it wrong, or, drop your keys on it. So what actually makes one piece of wood harder than another? Well, a couple of key things. First, dry wood is always harder than wet or green wood. Second, the dense inner part of the tree, the heartwood, is tougher than the outer sapwood. So you end up with this whole spectrum, from relatively soft woods like fir all the way up to incredibly hard woods like oak. Okay, for our final section, we're going to group a few properties together that honestly make wood seem like a natural superhero material. We're talking about its incredible built-in insulating powers. No, seriously, wood is one of the best natural insulators out there. And it doesn't just insulate against one thing. It works against three: heat, electricity, and sound. Let's start with heat. Wood has really low thermal conductivity. That just means it's terrible at transferring heat or cold. It's the reason a wooden handle on a hot cooking pot stays cool enough to grab, and it's a big part of why log cabins are so cozy and effective at staying warm in the dead of winter.
Next up, electricity. And dry wood is an amazing electrical insulator. It really resists the flow of an electric current, which is why it's been the go-to material for utility poles for like 100 years. But the key word there, and you probably guessed it, is dry. The second wood gets wet, its ability to conduct electricity shoots way up.
And last but not least, sound. Hey, remember that bundle of straws structure we talked about? Well, that same porous design is absolutely perfect for trapping and absorbing sound waves. It's why you see wood paneling in concert halls and recording studios. And it's why a library full of wooden shelves and tables just feels so wonderfully quiet and peaceful.
So here's the main takeaway from all this. None of these properties just exist on their own. They're all interconnected. That porous structure that makes it soak up water, that's the same structure that makes it a fantastic sound insulator. Its density is directly linked to its hardness, and its moisture content, well, that affects pretty much everything. It's all one big, connected system.
So from the floorboards under your feet to the chair you're sitting on, and yep, even that tricky door in the summer, every single piece of wood is this dynamic material constantly breathing and reacting to the world around it. Now that you know its secrets, I wonder, how are you going to look at the wood around you differently?